We knew that this test was coming at the very beginning of the year. The biggest part of the preparation involved the remote control of the tractor.
We had 3 different things we really needed to control: the throttle, the brake, and the steering.
Ryan and I came up with the concept of wireless I/O communication to control analog voltages and digital inputs and outputs in order to control the necessary components on this truck.
The remote control system of the truck included a console that had a steering wheel, a throttle pedal, and a brake pedal. And those actually were built from go-kart parts that then we built into a console for the driver.
The video feeds were absolutely critical to this application. We used a couple of IP cameras, one looking at the driving view, one looking at the speedometer, so that we would have almost instantaneous feedback.
We set up 3 antennae in the facility, and then those transmitted signals back and forth from the remote station to the tractor.
Craig, did it go 90?
About a quarter on the motor.
Yes, steer command's right at 17.
I was kind of the trailer guy. I took a lot of responsibility for making sure we had the load secured and offset, and also help coordinate some of the analysis to make sure that the trailer was going to provide a condition that would help for the truck to roll over. We actually engaged the University of Michigan Transportation Research Institute. We worked with them, gave them the specifications on the tractor, the specifications on the trailer, and they went through the modeling. We chose a path that is essentially what was done 10 years ago during the first rollover test that we did. And it involved a maneuver that would be similar to a truck coming up on a stopped car at 40 miles an hour and taking an evasive maneuver to the left to avoid the car, and then turning quickly back to the right to get back into the lane that the truck was originally in. Did the simulation at 37.5 miles an hour, and we found using that path with an unloaded trailer, we would not achieve rollover. But with 2 containers loaded at 3,000 pounds towards the back of the trailer on the left side, that we should achieve a rollover.
In Converse, we actually had to go up there several times to set up a driving path. We put cones up and painted a stripe on the surface to give us an actual line to follow.
We spent several hours just evaluating different routes with a manned driver.
We went through a lot of different things like calculating the G-force during braking, figuring out how many feet it was going to require to stop the vehicle in the case of an emergency stop, and also to accelerate the vehicle to 40 miles per hour.
Flying and releasing throttle.
That's about 2 degrees or so to the right.
We had to make sure that we set up our antennas for our video as well as our radio signals.
We wanted to have all areas of this 1,800-foot track covered. We had one at one end of the track, we had another one that was more directional at the truck, we had one at the control station, and then we also had one on the truck itself.
You see you passed the antenna, so just let us know when you start.
So when we first started driving, we only used the tractor because we really wanted to get a feel for driving without having too much of a safety concern. Then we transitioned to using the tractor and the trailer. The biggest challenge for driving this remotely was that you just didn't feel the vehicle. You can't feel the vehicle turning, you can't feel the vehicle's weight like you can when you're actually driving a vehicle. And there's also delays in the system, so it takes a lot of practice to kind of get to where you can actually maneuver the vehicle like you want to.
Can you see the orange cones down there?
A big part of it was compensating for that delay and actually steering or applying the brake before I know that it really needed to be applied.
The day of the test, a lot of preparations go into that.
Geez Louise, we couldn't ask for a better day. I mean, it was absolutely perfect. 70 degrees, no wind, so couldn't ask for a better day.
We have to get cameras put in place. I think we had 26 total cameras between onboard and offboard cameras.
And it was kind of business as usual. We'd done this, it seems like 5 or 6 times already, set up, tear down. So from there, just go through our checks, go through our checklist.
Prior to the test, we have a series of checklists that we go through. Verify motor controllers are on.
This is connecting now.
That's to check the modulation of the system to make sure the remote controls are working properly. We had to go through a lot of different things for the steering. The steering was a lot more challenging than the brake and the throttle.
Sometimes the potentiometer for the steering, we would have to calibrate it to make sure that when he turned the steering wheel 1.5 times, that the vehicle steering wheel turned 1.5 times. So there was a little bit of finessing in order to get this working as it should.
Any crash test, you really just have one chance to do it right.
One shot to get it right. I mean, that's how it is around Cape though.
When you are ready, I will rotate the RC steering wheel 90 degrees to the left.
Yeah, after we went through all of our pre-test checklists, we were ready to run the test.
At that point, I was ready to see the thing go, so now or never.
Launching vehicle with RC system at 3, 2, 1.
When we launched the vehicle, I was pretty honed in on that screen, and when you're driving a normal vehicle, you're kind of shifting left, shifting right to keep that vehicle straight, and you do the same thing with the remote control system, but during the test I had to stomp the gas full bore to get it up to speed, and I never touched the brake.
A lot of us, when we saw the truck finally roll over, was a big sigh of relief.
When it actually rolled over, it had about a million things running through my mind, but as soon as I saw the tires come up, I was super excited.
The ultimate goal of the test was to roll the tractor trailer over and to deploy the Rolltech system and evaluate its performance.
Well, Rolltech is a product that has been developed by EMI that helps protect and save the lives of truck drivers.
Rolltech deploys in a very fast manner. When the vehicle rolls, the roll sensor triggers, and the first thing that happens is the seatbelt is pre-tensioned and the suspension seat is collapsed. A few milliseconds later, the airbag is deployed to provide occupant protection for the occupant's head. It all happens in a matter of about 40 milliseconds. The results of the test were really phenomenal. We collected all the data, we collected all the videos. We didn't really have any glitches at all. It was all phenomenal.
The truck did roll as we expected, and subjected the driver to the conditions we were expecting it to, and Rolltech also played the role that we expected that to help save the driver.
While preparing and performing this test, we actually learned quite a bit. Myself personally and the other Cape personnel hadn't really designed a remote control system like this before, so going through that exercise really kind of tuned up our engineering skills and our skills to do things like this in the future.
The guys did a fantastic job of demonstrating their creativity and capabilities, even when there's some barriers in place that make it a little bit more challenging. But I'm sure as this gets out, what we've done, it'll only help us to bring new customers that are looking for other challenging tests. It was a great challenge and a great reward as well.